Okay, so let's start the Unit 1 review for the Semester 1 final. It's kind of a mouthful. Okay, so throughout this, I'm just going to kind of review the key points that will be on the final. There's not really much else on there. I try to keep it to just what's on the final and not any extra stuff. So let's start. This one starts pretty easy. So slope-intercept. So slope-intercept form is y equals mx plus b. So m is your slope, b is your y-intercept. So you plot, how you graph this is you plot your y-intercept and then you use the slope to make the rest of your points. All right, y'all been doing that forever. Okay, standard form, so starting to get a little bit trickier. So standard form is capital AX plus BY equals C. And so there's two different options to graphing this one. So you could either convert it to slope-intercept form, which is what I usually like to do sometimes, or most of the time I should say. The other way is to find your intercepts. Okay, so finding the intercepts. So your x-intercept is when y equals 0, and your y-intercept is when x equals 0. Okay, and then point slope is really not used to graph very often, but you still do need to know this formula. It's an important one. So y minus y1 equals m parentheses x minus x1. And this is used to write equations of lines. All right, so graph the following. First one, letter A, y equals negative 1/3 x plus 4. So you start at your y-intercept 4, then you go down 1 over 3 because of your slope. Draw a line to connect it. There we go. Okay, this letter B is in standard form, so I could convert it and get the y by itself so it matches that, but let's just do intercepts. So the x-intercept is when y equals 0. So 2x plus 3 times 0 equals 18. So 2x equals 18. So your x-intercept is 9. Your y-intercept is when x equals 0, excuse me. So 2 times 0 plus 3y equals 18. 3y equals 18, so y is 6. So how do you graph this? You put a dot at 6 on the y-axis because that's your y-intercept, and your x-intercept is 9. And then you just do your best, do better than I did to connect them. Okay, so that's graphing lines. So now let's talk about standard form a little bit more. So remember, these directions say write the following in standard form. Remember, no fractions or decimals in standard form. So standard form is AX plus BY equals C. AKA you get your constant, your C, over here by yourself and put your X and your Y on the other side. Okay, so how would I do that for this one? Well, I would minus 3x to move that over. Negative 3x plus y equals 4. X's and Y's are on one side. There are no fractions or decimals, so you're done. Okay, and so this next one, I'm gonna have to move that x term over by adding 1/3 x. So this would be 1/3 x plus y equals negative 6. Now, this one does have a fraction in it, so what do I need to do to get rid of that fraction? Multiply. When you multiply one thing, you must do the rest of the things. So we have, sorry, trying to get the right color. 3 times 1/3 x is just x plus 3y equals negative 18. And make sure you multiply to all three terms. Don't miss any of them. Okay, so now section 2.4, parallel lines. What do you remember about those? They have the same slope. Okay, those are the easy ones. Perpendicular are a little bit different. They are opposite and reciprocal slopes. So what do I mean by that? So an example, like if I had 2, the opposite reciprocal of that would be negative 1/2. If I had negative 1/3, the opposite reciprocal would be positive 3. Then one more, let's do 3/4. The opposite reciprocal would be negative 4/3. Okay, so that's what I mean about opposite and reciprocal. The sign changes and it flips to the reciprocal. Okay, so write the equation of the line parallel to the line this, okay, that passes through this point 6, 2. Okay, so these lines are going to be parallel, so that means they have the same slope. So the slope for this is 2/3, right? Because the old slope was 2/3, they're parallel, they're gonna have the same slope. Now 6, 2, this is our coordinate that we need to plug in. So I have a point, I have a slope, let's plug it into point slope. I'll write it right here for you. So we have y minus 6, or I'm sorry, y minus 2, my bad, equals 2/3 parentheses x minus 6. And let's go ahead. It doesn't say to convert it to slope-intercept form, but let's go ahead and do that just because. So this is 2/3 x minus, what would that be, 4? Yes. And one last step to get the y by itself, add 2. So y equals 2/3 x minus 2. All right, so write the equation of the line. Now this one is going to be perpendicular to this that passes through that point, negative 1, negative 2. So your new slope is going to be the opposite reciprocal of negative 1/3. So the opposite would be positive, reciprocal would be 3. And then you have your point, x1, y1 there. All right, let's go ahead and plug it in. It'll be y minus negative 2, so y plus 2 equals 3 parentheses x plus 1. All right, let's work our magic by distributing that 3 and then moving the 2 over, so I have y equals 3x plus 1. All right, absolute value functions. It's probably been a minute since you've graphed these. So how do you graph it? Well, these all start at 0, 0. Okay, and these are the ones that make the V's. And so the parent function is up 1 over 1 in both directions. Okay, so it's gonna look something like this. And don't forget your arrows. Okay, so that's the parent function. It starts at 0, 0, and then up 1 over 1. It's a consistent slope on both of them. All right, this little chart, does it look familiar from units past or previous units? Yes. Okay, transformations. If it's plus 2 inside the absolute value, that's going to be left 2. If it's minus 3 inside the absolute value, right 3. Plus 1 outside is up 1, minus 4 outside is down 4. A 1/2 out front would be a shrink with a scale factor of 1/2. 2 would be a stretch, scale factor of 2. And a negative out front would be a reflection, so it would be an upside down V. All right, so let's do this one. So all the things are happening. It's a reflection, stretch with a scale factor of 2, right 4, up 3. All of the things. So start with your vertex. So go right 4, up 3. And now it's a reflection, so it's going to be upside down. Don't forget that part. And then the scale factor is 2 on that stretch, so your slope is going to be 2 and negative 2. So down 2 over 1. Down 2 over 1, do it a few times. Okay, I'm gonna draw to connect. There you go. All right, this one. So I've got shrink, scale factor 1/3, and then up 4. That's it. So it starts at 4. Now this time the slope is positive 1/3 and negative 1/3. So up 1 over 3 in both directions. All right, so, okay, so let's talk about systems of equations. So if you have types of systems, okay, so if you have a system of equations, which means there are equal signs, then your type of answer is going to be a coordinate, or actually you should say coordinates, because sometimes there can be more than one, where they intersect. Oh, I spelled that totally wrong. There we go. Okay, so now if it's a system, so you have 2 equations or more than 2 equations. Okay, so inequalities, this is when you have all of the crazy fun symbols. So the type of answer is going to be the shaded region. And there are always infinite amount of answers. Okay, so let's graph this one. So A, is this going to be a system of equations or a system of inequalities? The answer is equations because of the equal signs, of course. All right, this first one, y equals negative x plus 5, that is a line. There's no absolute value. So go to 5, and then your slope is negative 1. So go ahead and do that. All right. Now let's do the absolute value one. So this one looks like it's shifted right 2, up 1. So right 2, up 1. Looks like there is no shrink or stretch, so it's up 1 over 1 in both directions. Okay. So how many times are these things going to intersect? And the answer is only 1 in this spot right here. And the reason, I don't know if you can see it, but on the left side of this, these are never going to intersect because these lines are both parallel. They have a slope of negative 1, so they will never touch. But this right here is your answer, and so we just need to name that coordinate since it's a system of equations. So that would be 3, 2 would be your answer for this one. Okay, now let's do inequalities. Don't forget about the solid and dashed line. I always forget, so I'm trying to help you remember now. So we have absolute value. This first one is going up 7, and it's also a reflection, and it's dashed. Yay. Okay, so go up 7, put your vertex, reflection, so down 1 over 1. And then don't forget the dashed line. All right, so there we go. And I could shade right now, so we will be shading below it because it's less than. I'm going to hold off on that because I have another one to graph. So this next one is just up 1. Right, so up 1, no reflection, no shrink or stretch, so it's up 1 over 1. But it is also a dashed line, so keep that in mind. Okay, so now we need to shade. So that blue one we're shading above it because it's greater than, and the red one we're shading below it. So the region that will satisfy both of those inequalities is this right here. Which, what does that mean? How many answers are there? The answer is there's an infinite amount of points because there's all the little decimals and stuff in there. So there's an infinite amount of solutions for something like this, and all of them are in that green region. Okay? Linear programming, the last part for this. Okay, so this is the one where you graph the inequalities. So usually there's around 4 of them. Form the feasible region, so that's the shaded region for all 4, or however many inequalities there are. Find the coordinates of each vertex of that region, and then evaluate it for p or whatever function they give you for each vertex. So let's begin. So first we have x plus 2y is less than or equal to 5. So I prefer to convert these to slope-intercept form. So this will be 2y is less than or equal to negative x plus 5. Divide by 2. So y is less than or equal to negative 1/2 plus 5 divided by 2 is 2.5. Kind of gross, but it'll be all right. All right, now the second one was x minus y is less than or equal to 2. So minus y, negative y is less than or equal to negative x plus 2. Divide by a negative 1 and flip your sign. Don't forget that part. So you have y is greater than or equal to 1x minus 2. Okay, so let's graph this. The blue is going to be at 2.5, which is a little weird, but it's fine. Oh, I forgot the x in there. Down 1, so to 1.5 over 2. Let's do it again. Down 1 to 0.5 over 2. One more time for fun. Down 1 over 2. Okay, so like here's that point. It's kind of hard because I don't have notability, but I'm doing the best I can. All right, so then the red one was started at negative 2. Up 1 over 1. Okay, and this is a solid line. All right, and then let's talk about the bottom 2 constraints. So x is greater than or equal to 0. That's going to be everything above the, I'm talking about x. Oh, back up. X is greater than 0. It's all of these. So it's going to be over here. And then y is greater than or equal to 0. It's this one. So, and then the top one was y is greater than, so it would, 1x minus 2. And then the blue one is less than, so it'll be right here. So long story short, which region satisfies all of that? And that would be this right here, this little baby region. Okay, so now we have our feasible region is what that's called. So we need to find all of the coordinates that make the corners of that region. So we have one here, 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 and here. There's 4 corners, right? Let's go ahead and label them A, B, C, and D. Just, I don't know, it just kind of helps. So let's put them over here. So A is at 0, 0. B is at, that's a decimal and it's okay. It's at 0, 2.5. Remember that was our y-intercept. C is actually a whole number. That's 3, 1. And then D would be at 0, 2. Or sorry, 2, 0. My bad. It's been a day. Okay, so now we've done all that. Now, what am I talking about? Evaluate. So if you look up here, it says what point in the feasible region minimizes p for the objective function that. So we're looking for the minimum value of that. So your p is equal to 2x plus y, right? So we're going to be plugging in those values, and some of you may be able to see it, but that's okay. So it's going to be 2 times 0 plus 0. Well, that's 0, right? And this one's going to be 2 times 0 plus 2.5, be 2.5. 2 times 3 plus 1, be what, 7, and then 2 times 2 plus 0 equals 4. Okay, which one is the minimum? It would be this one right here, right? That's the smallest number. So your minimum would be at 0, oops, sorry, give the coordinate, 0, 0, and it equals 0. Okay, if you if it wanted the maximum, you would say the maximum was at 3, 1, and it was 7. All right, last one, same directions. We need to graph all of this. I'm going to start by converting. So I have y is less than or equal to negative x plus 5. And then the other one was 2y is less than or equal to negative x plus 8 divided by 2. You don't need to flip the sign this time, right? Okay, so we got that. And then x is greater than 0 and y is greater than or equal to 0. Okay, so let's graph. We start at 5 and your slope is negative 1. It is important to graph these nicely so you can see which coordinate's which, because it can really mess you up if you're sloppy. Okay, and then, oh, see, I can't even read my own writing. Plus 4. So we start at 4, and then down 1 over 2. And it's greater than, or x is greater than 0, and y is greater than 0, so we're staying in that first quadrant. And here is our feasible region right there. Okay, let's, just to make things easy, I'm gonna label it again. So A, B, C, D to our 4 corners. And that's just kind of a me thing. You do what you want. So A is 0, 0. B is 0, 4. C is at 2, 3. And then D is at 5, 0. Okay, so this problem wants the one that maximizes our function. We do have a new function for this. So P equals 3x minus y. So let's plug all that in for the x and the y. So 3 times 0 minus 0. For sure, not going to be the max. 3 times 0 minus 4 would be negative 4. 3 times 2 minus 3 would be what? 6, 3. And then 3 times 5 minus 0 will be 15. So your max for this one is at 5, 0, and it equals 15. Perfect. All right, that is it. Thanks for watching, and have a great rest of your day.